Okay, so now we see how the orbital radii um, are can only take on discrete quantized values related to this Bohr radius here, which we've just calculated its numerical value, by the principal quantum number n, an integer, squared, divided by the atomic number of the nucleus, z. Okay, these are both integers. All right, so now if we look at this, even just expression for the kinetic energy, we see that if we plugged in these discrete values for r, then we're going to get discrete values for the energy. And if we go all the way back to where we wrote the expression for the total energy of the electron right here, okay, what we see is that the electron has an energy of minus 1 over 8 pi epsilon naught times the atomic number z e squared over r. So now we're going to plug in the quantized values for r. We're going to plug in these quantized values, and we're going to see what values of energy that gives us. Okay, so I've written that down now. I've written down the relationship between the total energy and the quantized orbital radii. And so now if we plug in for Rn here, if we plug in these values, a naught times n squared over z, okay, then we get this is equal to minus 1 over 8 pi epsilon naught times z squared e squared over a naught n squared. Okay, and again we can use our little trick here. We can rewrite this using we can leverage, if we want to actually calculate the numerical value, we can use the fine structure constant. Okay, this again is alpha, is equal to 1 over 137, and then times h bar c over 2a naught times z squared over n squared. So if you look at this right hand side, you'll see that it equals to, once you cancel factors and whatever, you'll see that it equals this expression here. Okay, so this allows us to try to calculate numerical value. So what we find is that let's now before I do that, let me say that this combination of constants here, alpha times h bar c over 2a naught, this has units of energy, because again these are just two integers, z and n are just integers, and so we can basically call this E naught. Okay, and so we can say that En is equal to E naught times z squared over n squared, where E naught is equal to minus e squared over 4 pi epsilon naught h bar c times h bar c over 2a naught. We're dividing things like this just so that it makes it easier to calculate. Okay, so now I'm going to basically write down the numerical value, numerical values for both of these terms. Okay, this one, and this one, and so we can calculate a total numerical value for the energies. Okay, so here is the second term here, h bar c over 2a naught is just equal to 100. H bar c is 197 eV nanometers. 2a naught is 2 times 0.0529 nanometers, so that's equal to 1862 electron volts. This term here is the fine structure constant. We already wrote it down. It's 1 over 137. So when you multiply them together, you get 1862 divided by 137 is equal to 13.6 eV. So E naught is equal to minus 13.6 eV, and so the quantized quantized value of the energies, the electron energies, the total energies of the electron, is equal to minus 13.6 eV times z squared divided by n squared.